Welcome in Dark Core. October 2025 offers sky watchers a rare opportunity. Comet A6 Lemmon, a long-period comet returning after more than 1,000 years, is making a brief appearance in the evening sky. It's not a bright, dramatic comet, but it's already outperforming early brightness predictions and will pass near Earth just as Comet R2SW makes its own close approach. For astronomers, this alignment isn't just a spectacle. It's a valuable scientific window. In this video, we'll unpack what makes A6 Lemmon's return significant, how it behaves as it approaches the Sun, and what to expect in the coming weeks. Let's get started. Discovery and orbital details. Comet A6 Lemmon was discovered on January 3, 2025, by Dick Carson Foss during the Mount Lemmon Sky Survey. At the time, it was just a faint speck, but orbital calculations quickly revealed its uniqueness. This is a long-period comet completing a journey that spans approximately 1,350 years. Its last visit occurred centuries before telescopes existed. After this passage, a gravitational encounter with Jupiter will shorten its orbital period slightly to about 1,150 years. This subtle but measurable shift illustrates how planetary interactions reshape cometary paths over time. The comet will make its closest approach to Earth on October 21, 2025, at a distance of about 0.596 astronomical units. Just over 2 weeks later, on November 8, it will reach perihelion at 0.53 astronomical units, roughly between the orbits of Mercury and Venus. Unlike many short-period comets, A6 Lemmon approaches the inner solar system on a steeply inclined orbit, giving it a distinct path across the night sky. In early October, it passed beneath the Big Dipper in Ursa Major and has now transitioned into the western evening sky, visible low after sunset. Observers describe the comet's faint greenish glow caused by C2 molecules fluorescing in solar ultraviolet light. This green hue isn't unique, but it signals increased activity as the comet warms. And here lies the surprise: A6 Lemmon is brightening faster than predicted, making it easier to observe than initial models suggested. No, it won't be a dazzling naked-eye object like Comet Hale-Bopp once was, but its reliable orbit, increased brightness, and rare return make it a prime target for amateur astronomers and research teams alike. Scientific importance and theories. Comets like A6 Lemmon are more than celestial visitors, they are archives of the early solar system. They carry pristine material from the solar nebula preserved in deep freeze in the Oort cloud. Studying them offers insight into the composition and evolution of the outer solar system. The green coloration is produced when diatomic carbon, C2, in the coma is excited by solar UV radiation and fluoresces. By examining the relative abundance of gases like C2 and Cn, scientists can infer where in the solar nebula the comet originally formed and how its chemistry has changed over time. Equally important is the comet's brightness evolution. Predicting a comet's light curve is notoriously difficult. Early brightening suggests that volatile materials on the surface are becoming active earlier than expected. Monitoring these changes as Lemmon nears perihelion helps refine thermal models and improve our understanding of long-period comet behavior. Orbital evolution is another key aspect. Encounters with Jupiter, even distant ones, can shift cometary trajectories by millions of kilometers. Tracking A6 Lemmon through this passage provides valuable data for refining long-period orbital dynamics and understanding how Oort cloud objects evolve over millennia. Finally, its coma and tail development offer a real-time laboratory for studying outgassing processes. Any sudden brightening or morphological change could indicate localized outbursts or fragmentation. Comparing its behavior to previously studied comets like 67P, Churyumov Gerasimenko helps build a broader picture of how different cometary types respond to solar heating. In short, this isn't just another faint smudge in the sky. A6 Lemmon's orbital characteristics, activity curve, and chemical composition make it a scientifically valuable event even if it remains modest to the naked eye. Implications and what's next? For observers, the best window to see Comet A6 Lemmon is mid to late October, roughly 45 minutes after sunset. Look low on the western horizon with a clear view, buildings or trees will block your sight line. The comet won't climb higher than about 20 degrees, so location and timing are key. This apparition is especially well timed. The Orionids meteor shower peaks around October 20th to 21st, and the new moon ensures dark skies. That means observers can potentially spot both a meteor display and a comet in one night. For most, binoculars will be sufficient to spot a faint green patch in the sky. A small telescope will provide more structure, revealing the coma and possibly a short tail. For astrophotographers, even short wide-field exposures can capture it. Stacking images over multiple nights reveals the comet's changing position and morphology. What makes this moment even more compelling is the coincidence of multiple celestial visitors. R2 Swan will pass Earth just one day earlier, and the faint interstellar object 3I Atlas will be visible for experienced observers with larger equipment. Such overlap is rare and provides an opportunity to compare cometary behavior under similar conditions. Professional observatories are monitoring Lemmon to better understand its activity curve and orbital evolution. This data contributes to refining models of long-period comet behavior and helps us better predict how such objects will behave in future apparitions. After perihelion in early November, the comet will gradually fade, moving southward and becoming more visible from the southern hemisphere. By early 2026, it will vanish from our skies entirely, beginning another 1,000-year journey outward. For most of us, this is the only chance in a lifetime to observe Comet A6 Lemmon. Comet A6 Lemmon is a quiet but rare visitor from the edge of our solar system. Its brief October appearance offers both beauty and scientific value. If skies are clear, look west after sunset, you won't see it again in this lifetime. Thanks for watching Dark Core.